Welcome back. Today we are discussing about shear force diagram and bending moment diagram. Shear force diagram. It is graphically representation of the shear force plotted as ordinary on base line represented the axis of the beam is known as shear force diagram. Procedure to the follow for the diagram of shear force diagram. Number 1. There are 10 points are there of the shear force diagram. How to draw the shear force diagram? There are 10 points. Number 1. Draw the loading diagram of the beam. Number 2. Find reaction of the supports and draw a line below the loading points. Number 3. Start always from left side of the beam as far as load, whether it is up or downwards, and continue till right end of the beam. Number 4. By the time it reaches right end, it has to reach 0 of the baseline, otherwise your reaction calculation may be wrong or loading calculation may be wrong. Correct it immediately. Number 5. Positive values are plotted above the baselines and negative values below the baseline, and hatch it properly and indicate place positive and negative. Number 6. Mention the values of the shear force at each corner of the diagram. Number 7. Find the maximum positive shear force and minimum negative shear force values. Number 8. Where shear force crosses positive to negative, or the bending moment will be maximum at those points. At some places it crossing baseline, not at nodal point, especially under UDL. Find x distance where it crosses baseline by using similar triangles. Number 10. For point load, draw vertical lines. Under UDL, draw slope lines. Next topic is bending moment diagram. It is graphically representation of the values of the bending moments plotted as ordinary on the baseline represented the axis of the beam is known as bending moment diagram. Procedure to the following by drawing of bending moment diagram. Number 1. Calculate the bending moment at different silent points with sign positive or negative. Number 2. Draw the baseline and plot the positive values of bending moment above at baseline and negative values of bending moment below the baseline. Number 3. In between point load, draw slope line, and between UDL, draw parabolic lines and watch it properly. Number 4. Find the maximum positive bending moment and negative bending moment values it occurs. Next topic is standard cases of cantilever or simply supported beams. Case 1. Cantilever beam. Case 1. Cantilever beam subjected to point load at the free end. Consider a cantilever beam of span L carries a point load of a free end. Free end L distance shear force shear force at any section of a beam is equal to positive load. F of x is equal to load f of a is equal to load in shear force. Both are given shear force or load is taken. In this cantilever beam, shear force taken load consider the load. Next BM bending moment. Mx is equal to W into X. Therefore, MB is equal to 0. MA is equal to WL. Maximum bending moment occurs at A is equal to max MA is equal to WL. In this cantilever beam, bending moment acting at point WL means load into distance. Load into distance. To draw the shear force and bending moment diagram, cantilever is a free end. In point load, shear force acting at a it is 0. It is W 0. SFD BM react at 0. It is A is A, it is B, it is WL acting of the bending moment. It is negative bending moment, it is positive bending moment, it is L, it is X. Here are the shear force and it is W. In cantilever beam, it point load with shear force and bending moment diagram. You see this. It is bending moment diagram. BMD. Case 2. Cantilever beam subjected to UDL over the entire span. Consider a cantilever beam of span L meters carrying a UDL W kN per meter. Total load is equal to, we have discussed, total load is equal to WL. Total load is equal to WL. Then write shear force SFD FB is equal to 0. Either now acting at the shear force. If X is equal to WX, if A is equal to WL, either acting over the shear force WL. Maximum shear force occurs at A is equal to WL. Next, BMD, bending moment diagram. Next, movement at B is equal to 0. No movement at the B. In cantilever beam, M of X is equal to WX into UDL. We did X by 2, we given the where minus WX square by 2. Moment at A, WL into L by 2 minus WL square by 2. Therefore, maximum bending moment occurs at A. Max is equal to MA is equal to minus WL square by 2. Maximum bending moment occurs at A. Maximum shear force at A WL. Bending moment WL square. In cantilever, UDL, overall span of the UDL load. Case 3. Simply supported beam subjected to point load at the center. It is not cantilever beam. It is a simply supported beam with point load. We have taken simply supported beam. One minute. Supported beam and carrying point load in the center W. It is A, it is B. In this case, simply we find the reactions. It is center L by 2. The distance it is L by 2. In the reaction RA, it is RB. Firstly, to find the reactions. Firstly, to find reactions. The given load of the beam is symmetrical, hence RA is equal to RB is equal to W by 2. Shear force at any section is left of the beam W by 2. Shear force at a section is right of the beam is negative load by 2. In shear force the shear force diagram, SFD, shear force at any section in the left of the beam, half of the beam, is equal to positive load by 2, shear force at any section in the right half of the beam negative load by 2, shear force. Next, BMD. In bending moment diagram, in simply support, both end sides are 0. Both end sides or both supports are 0. Then MA is equal to MB is equal to 0. They only find the reaction of center or MC. MC is equal to W by 2 into L by 2 is equal to W by 4. It is sagging. Maximum bending moment occurs at C. M max is equal to MC is equal to WL by 4. We draw the shear force and bending moment diagram. That's right. Maximum at center bending moment, both ends are 0. W by 4. It is W by 2. It is negative W by 2. It is positive bending. It is negative bending. It is W by 2. It is 0. It is 0. Both ends are 0. It is C. It is shear force SFD. It is BMD. Right. Next case 4, simply supported beam subjected to UDL over the entire span. In case simply supported beam which UDL entire span. In further case, we have only simply supported only point load. In this case 4, we are purely UDL load. Shear force, bending moment, which cause behavior. Case 4. Consider a simply supported beam of a span L carry a UDL of unit length W by unit length by kilometer W by unit length over the entire span. This total load is equal to WL. To find the reactions, given loading of the beam is symmetrical, hence RA is equal to RB WL by 2 SFDR FA is equal to positive WL by 2 FC is equal to 0 FB is equal to negative WL by 2. Maximum positive shear force occurs at A is equal to WL by 2 and maximum negative shear force occurs at B negative WL by 2 in BMD, bending moment diagram. In this case, same cantilever beam, we are bending moment are maximum 0, both supports are 0. In this case, both supports are 0. We have maximum bending moment at center, which case, in case MC is equal to WL by 2 into L by 2 minus WL by 2 L by 4, which is WL square by 4 minus WL square by 8. We have LCM, we got 2WL square by WL square by 8, 2 minus 2 WL square by 8. The maximum bending moment occurs at center is equal to MC is equal to WL square by 8. Okay. In this class, we are discussing about shear force diagram and bending moment diagram in standard cases of cantilever beam and simply supported beam. Revise the cases. Case 1. Cantilever with point load L distance. You have shear force formula W. It's acting at maximum shear force acting at supports. Bending moment in cantilever minus negative occurs at A, it is B. Maximum bending moment occurs at A, which has W L. Bending moment formula. Case 2. Cantilever beam subjected to UDL over the entire span. Over the entire span. It is L distance. It is W per unit length. It is A. It is B. The shear force formula are W L. W means load, L means distance. Shear force. Bending moments formula are W L square by 2. Negative element. Bending moment occurs at A. Shear force occurs at A. Case 3. Simply supported. It is A, it is B, it is point load. Point load. Shear force formula are W by 2. Bending moment formula are maximum bending moment occurs at C, middle. Occurs at WL by 4. Maximum occurs at C or middle point. Middle point. Case 4. These are very important formulas in simply supported beam subjected to UDL over the entire span. Horizontal span, that is W unit length. It is A, it is B. It is shear force formula or W L by 2. Bending moment formula or W L square by 8. It's C pan maximum bending moment. C occurs in middle or C or C middle point. Okay, in this class we are discussing about shear force diagram and bending moment diagram and standard cases of cantilever beam and simply supported beam. Furtherly, we solve the problems. Okay, while closing the classes. Thank you.